Okay, so now you know how the framework works. Let's actually make some new players in it. So let's start by looking at the always rock player because it's the simplest example. Well, actually, before we do that, you might have noticed that all of our specific classes that determine strategies are getting saved into a player variable. And so you should think to yourself, how do you think that's happening? You should have a definite idea at this point. Probably you are thinking, oh, I know. I bet that the beat last move player is a child class that extends a parent class called player. And you are almost right, but actually we're using a slightly different mechanism for this. So let's go inside always rock player. So you might notice that public class always rock player does not extend player, it implements player. And that's because player is not a parent class. Player is a different kind of thing called an interface. And let's take a look at it. Here it is. So let's delete the comments for the moment, just to kind of show you what the class looks like. Sorry, not a class, an interface. So here's what the interface looks like. You see there's not a lot of code here. Public interface player, and then there's just two method signatures, but no method bodies. So what this does, so what all interfaces do is they're sort of like the template for a class. They tell you what a class is going to be able to do without actually providing any implementation. So without actually showing how it's going to achieve those things. So a good kind of bumper sticker phrase would be, an interface is the what without the how. So the what is a player is going to be able to provide a move and save information about the previous round. Those are the two things that players can do. But anybody who's going to be a player has to decide for themselves how these two methods get implemented, which is why there are no method bodies. Okay, so I put the comments back in. So here we are back at always rock player. So, well, here, let's actually, why don't you do this along together with me? This will be more instructive. So let's make a new class. Oops. Okay, that was weird. Let's make a new class. Oh, did it create a file down there somewhere? Well, it's not important. Okay, so let's call this, I don't know, random. Well, we already have a random player, don't we? Let's call this the always paper player. So rather than type out the methods, you should start by saying implements player, like this. And as soon as you do this, you see a compile time error, and if you hover over it, it says class always paper player must either be declared abstract or implement the method get move. So what that means is, as soon as we claim that our class is implementing an interface, it's like we are signing a contract. We are agreeing that our class has to have the methods that are given inside the interface. So if you hit Alt-Enter, you can say implement methods, and it will create the method stubs for the methods. And you see this @ override, which is an annotation kind of cluing us into the fact that we are implementing the methods defined by the interface. And we've got these kind of default implementations. Instead of this, we're going to say rock, paper, scissors, scissors. So that's what getMove does. And then here, we're going to leave this empty because if we always play scissors, there's no point in us saving information from the previous round. So now I've got a successful implementation of the player interface. And because I do, back in run me, I could have the always paper player. And like my framework will be able to run the methods in my class because being a player, implementing the player interface, guarantees that my class will have those methods. Okay, so two questions. Why bother having an interface? Why isn't this a parent class? And the answer is because there's actually no attributes and there's no code, there's no implementation of methods that would get inherited. Like what it means to be a player is to be able to do these two things, but there's no kind of generic general, code to provide that I'd want my children to inherit. So if I had a parent class, it would be kind of an empty parent class. So that's kind of one reason. A different reason is when you make something an interface, you can see that anybody who implements my interface, their code will just plug and play directly into the rest of the framework. So it's sort of like I'm defining the structure that somebody else's code has to have in order to interface well, in order to work well with my existing code framework. So that's really nice because I could actually publish this. I could compile all of this code so that nobody has access to the source code for this at all. So they wouldn't be able to edit the README file. They wouldn't be able to edit any of this other stuff. But if they wanted to, they could still implement new players. And as long as they're putting their compiled players in the right spot, it would still be able to interface with my existing framework. So it's like a nice flexible way of programming your framework in an open way that lets other people extend it or add into it. All right, so hopefully you know enough now to do the assignment. Good luck in implementing all of the non-Markov strategies, and then when we come back from break, we can implement a couple of Markov strategies. Good luck.